Alright guys, I'm going to be going through the solutions to the CSEC June 2022 CSEC physics paper, alright? So you guys got a really easy physics paper here, right? Alright, so this question is very similar to a question that came in June 2015, right? The activity of a radioactive substance was measured over a 6-minute period and the results are recorded. So we have activity, that's disintegrations per minute. And what they want us to do is to draw, one second. Just give me 1 sec, hold on. Yeah, so essentially what they want us to do is to plot a graph of activity versus time for 8 marks, right? So this here, your activity, right, is going to be on your y-axis and your time has to be on your x-axis. So before you even plot the graph, you should have an idea of what it should look like, right? And essentially what we're going to have here is activity, we're going to have time, and we expect that the graph is going to look like this because it's going to be a decay curve, right? So first things first, I want to get that data next to my graph paper. All right, so this is what I'm trying to plot here. Right, so in this instance here, these are my x values and these are my y values. Now what you have to do is to look at your x values. So the smallest value is 0 and we're going up to 6, right? So on my x-axis I'm going to put 0. Let's see what scale I should use here. 1, 2, 4, 5, 6. So I'm going to use, this is 1, this is 2, 3, 4, 5, and 6, and we need to label the axes here. So I'm going to label that t in minutes, all right? Because that's the unit that they have there, t in minutes, right? Let's see what else we want now. Right, so that's my scale on my time axis. On the y-axis now, you look at your data. The largest value here is 80 and we're going down to 4, right? So let's see what scale we're going to use here. 10, 20, 30, 40, 50, 60. All right, let's go like this. 10, 20, 30, 40, 50, 60, 70, and 80. Right, and we need to label this. You get a marks for doing all of that. So we're going to put activity A, and our unit here again is disintegrations per minute. So therefore this is minute to the power minus 1, right? That's my unit. So you're all getting marks for this, right? Label your graph. So you're going to say graph of A, right, against T, right? That's what I'm going to use here, A against T. The scale, well, you could specify the scale. The scale I'm using here on my x-axis is, so on the x-axis, I'm using 2 cm, right, to represent 1 minute, right? That's what I'm using there. And on the y, I'm using 2 cm to represent 10, right? And you need to put this on the graph, right? You all need to put this on the graph. So let's start plotting here. 0 against 80. That's going to be this point here. That's 0 against 80. Right, so that's this one. Next one, 1 against 50. So 1 against 50 is going to be here. Next one is 2 against 35. 2 against 35 is here. Right, 3 against 22. That is down here. 4 against 13. This is 10, 11, 12, 13. Right, and then 5 against 8, that's here, and then 6 against 4, that's down here, right? So those are my points, right? And all I need to do now is to draw a smooth curve that kind of passes through them, right? That's what we need to do. So this was pretty straightforward. If you had done the June 2015 paper, right? Basically, it's the exact same question. They just change up the numbers. All right, so I don't want to draw this freehand, so let me just use something here that I can use. Right, so in the exam, you all would have had to draw a smooth curve through this thing. All right, let me see if I can get a kind of smooth-ish curve. Hold on. I don't like how this looking as yet. Yes, no. Just give me a sec here. All right, the point is I want to show you the gist of what we're doing here, right? But you're going to take your pencil and you're going to draw a smooth curve passing through these points, right? So this is my graph here. So my answer may be slightly different to you guys, right? It might be slightly different. Okay, so that's it for 7 marks, right? That's all, 8 marks, that's it. The next thing I want us to do is to define the term half-life. So if you all watched the live I did previously, the night before, half-life is a definition we need to learn, right? So all we need to do is to tell them, right? So half-life is the average time, right? Time taken for the activity to decrease by half the initial value. Right? That's it. Straightforward definition, nothing complicated there. Right? Next part. From your graph, calculate the average half-life. Now, the fact that it told us to work out average half-life there, what we're going to do, we can't just use one set of data and work out our half-life. Right? You can't do that. You need to do it at least twice. Right? All right, I'm just watching the chat there. Let me make sure I don't have a mistake in the graph though. 10, 20. Oh, okay. Let's fix this, guys. I have a mistake here, man. One sec. I'll fix. I see any problem. Alright, so this is 20, 10, 20, 30, 40, 50, 60, 70, 80. Alright, let me double check to make sure. 10, 20, 30, 40, 50, 60, 70, 80. Right. So let me just plot it back quickly. Right. So the first point was this point here, 0, 80, then 150. Right, so that's here. Next one is 235. So that's down here. Right, so hopefully I get a better curve this time. 2 against 35, 3 against 22. So that's here. 4 against 13. Right. 5 against 8. And the last one is 6 against 4. Right. So yeah, don't worry, I saw the mistake, right? I saw the mistake. It's kind of hard when you're trying to do this on a screen. If you're doing it on an actual graph paper, it'll be much easier. All right, so let me just, all right, so this is looking a little better. All right, so I'll go with this curve here. All right, so I'll go with this curve here. All right, so the next part, they want the average half-life. So what we're going to do, right, you could start with your initial value of 80, and what we can do, we can find the time taken to decrease by half that amount. So what I'm going to do here, so let's insert a line. All right, so first things first, we know where the 80 mark is. So what I'm going to do, I'm going to read off at the 40 mark, right? So when I read this off here, what I'm getting, right? Now, my answer, like I said, it might be slightly different to what you had, right? All right, so that my first half-life there, I'm getting 1.5 minutes, right? So here's how you're going to write this up. So your initial activity, right, was 40, right? And that's 40 per minute. So not 40, sorry, 80 per minute, right? And that time corresponds to 0. Your activity changed to 40 per minute, right? And that time that we are getting here, or I'm getting here, is 1.5. So this is 1.5, right? So therefore, for this instant here, my half-life is equal to 1.5, right? Minute. So that's one test we can do here. Now I'm going to use, what I can do, I can also do it for the half of the 40, which is going to be 20. So I can do it here as well. All right, so let's write down our times here now. So at 40, so your activity here, right, is 40, and that is corresponding to a time of 1.5 minutes, right? Then our activity now is 20, and that is corresponding to a time, according to my graph, I'm getting a time of about 2 minutes, right? So what that is going to do, that is going to give me a half-life of 3.2 minus 1.5, and I'm going to get 1.7. Right? Now the question asks for average half-life, so you're going to put average half-life, right, is going to be, in my case I did it twice, so 1.5 plus 1.7, and I'm going to divide that by 2, right? And I'm going to get about 1.6 minutes as my half-life, right? So it's something like that they want us to do, right? So like I said, the answer will vary from person to person depending on how you draw a graph, right? Next one, on your graph, use dotted lines to determine how long it will take for the activity to be reduced to 10 disintegrations per second. So all they want us to do, go back to the graph, and you're going down to 10. And you're going to read this off here. Right? According to my graph, I'm getting about maybe 4.6 around there. Yeah, I'm getting around 4.6. So it depends on your graph. So this here, you're getting 2 marks just for saying 4.6. right? And that's it. So that was a very, very easy graphical question, right? Very, very easy. Next part, define the term nuclear fission. So if you all listened to me the night before, I told you all what fission was. So it's a process by which a heavy, unstable nuclei breaks into two or more smaller fragments with the release of energy. Now they only give you 1 mark, so any valid thing will work. Right, so 1 mark for that. Next part now. So last night I was about to do a question like this, and I told you all this is the exact same equation, right? Because this equation comes a lot in the exam. It's the exact same thing. Using atomic mass data, right? Calculate the energy released in this reaction here. So there are 2 things we need to do. We need to find the total mass on the left, total mass on the right, and then from there now we can work out the energy that is released in the reaction, right? So on the left hand side, we have this uranium-235 and 1 neutron, right? So all we're gonna do on the left hand side, I guess I could work this right here. On the left hand side, right, we're gonna add uranium-235, so that's 235.118 plus you have a neutron there. So this is my uranium here, that's my neutron. So plus 1.009. So let's add that. 235.118 plus 1.009. And I'm getting 236.127U, right? When you're doing these questions, try never to round off. On your right hand side now, you gotta be careful here now. Let's see what we have. We have krypton, barium, and we have 2 neutrons. So you're gonna add your krypton and your barium. So the krypton is 89.847 plus the barium, which is 143.881 plus, now this is where students will make a little mistake. You have 2 neutrons here. So you have to make sure you add 2 neutrons. So it's going to be plus 2 multiplied by 1.009. Right? So let's add that there. So I'm going to multiply the 2 by 1.009 plus 143.881 plus 89.847. And what I'm getting here now is 235.746U, right? So you know the total mass on the left, total mass on the right. So what we need to do, we need to work out our mass defect. So your mass defect, right? Now, since you're releasing energy, your mass on the right will always be less than the mass on the left. So it's going to be 236.127, 236.127 minus the mass on the right, which is 235.746, 235.746. Right? So that's going to give me my mass defect, but it's going to give me my mass defect in U. So 236.1 minus 235.746. And I'm getting a mass defect of 0.381. And that's U. Now, before we use the equal MC squared formula, right, I need to convert that U into kilograms. I told you all that last night, right? So your mass, right, so your mass defect in kilograms now is 0.381 multiplied by, they gave us this here, 1.66 by 10 to the minus 27. 1.66 by 10 to the minus 27, right? And that's the converted to kilograms, right? And I'm getting 6.3246 by 10 to the minus 28 kilograms, right? Now we can go ahead and use the energy formula. So your energy released is going to be mc squared, which in this case, you have to take that mass you just got, which is 6.3246 by 10 to the minus 28. And you're going to multiply by the speed of light squared. This is the next place students make errors. And I'm getting this number here, 5.69214 by 10 to the minus 11 joules, right? So I don't know if you all got anything looking like that. And that's it. That's it for like, that's it like for, so exactly what I told you guys last night, right? That same question basically came, right? I also told you the mistakes that students make, right? The mass can be negative. See somebody asking the mass can be negative, and you have to remember to square your, square the speed of light, right? So moving on, question 2. They want us to complete this table here. What we have here, they have some physical quantities and they want us to, all right, so meter squared, that has to be area, right? So 1 mark for that. Density, if you all remember what density is, it's mass over volume. So that is going to be kilograms divided by meter cube. So the unit here is going to be kg m to the minus 3. So 1 mark for that. And then they gave us kilogram meters per second squared. And then some people might be like, well, what is that? But you could have done it like this. Kg ms to the minus 2. This is mass. This here is acceleration. So if you all remember Newton's second law, F is equal to m by a. So this is actually force, right? That's actually force. And then the last one, velocity. Well, velocity is meters per second, right? That's what that is. Right, so that's 4 marks here. Let's see what else they want here, right? 1 sec. Okay, state Newton's second law of motion, right? Newton's second law, the rate of change of momentum is proportional to the applied force and takes place in the direction in which the force acts. right? So this is my Newton's second law here, right? Some students may want to say, well, F is proportional to mv minus mu over t, right? That's basically what Newton's second law is, right? But this is a statement that they want, right? So that's it. The next part here now, they want to know a basketball has a mass of 500 grams, calculate the weight. This is like a baby question, right? Weight is given by m by g, right? But the thing is, the mass has to be in kilograms. So if you have 500 grams, that is actually 0.5 kilograms, right? So we work it in kilograms here. So this is 0.5 multiplied by g. They gave us g here. G is 10. So the answer is simply 0.5 by 10, which is going to be 5 newtons, right? So 3 marks for that. Easy stuff. All right, so 3 marks for that. Next part here now. So if you all remember last night, I did one exactly like this, right? They say you have a scale drawing here, right? Now let me see if I can do this quickly for you all. Figure 2 is a scale drawing of a vector representing a basketball velocity, OA, right? And the wind velocity is OB. Complete the scale drawing to determine the resultant velocity of the basketball, right? And you want to do that for 3 marks. I'm not going to do my fancy stuff, but let's see what they want here. They want the magnitude of the resultant velocity and the direction in degrees from the wind's. Okay, so let me show you what you have to do here, right? We did this last night. Let's give me a sec, right? I wanna. Now the diagram is drawn to scale, right? But that's all. All right, so this is it. This is the diagram here. So this is precisely what I showed you guys last night, right? All you need to do, you need to take a compass, right? And you're constructing a parallelogram. That's essentially what you're doing. So you're gonna just open this compass to this length here, right? Let's change that to red, right? And this is all you guys had to do here. So you open the compass to that length, right? And we come across here, right, to the end of this, and you're going to draw an arc, right? Because that's what we're doing, we're constructing a parallelogram. Then all you're going to do now, right, bring this across here. Right, that's it. Let me just see something. What they want. They want us to complete the scale drawing, right, to determine the resultant velocity, right? So all you need to do here to figure out the resultant velocity now is to complete the parallelogram. Where's my ruler? All right, so let's take a ruler, place it at this point here. Right. Right, so this is what we need to do. And after you do that now, the resultant velocity that we want to get, right, you're going to have to So you're drawing this line here, and this green line here will represent your resultant velocity, right? But, one sec. So this here is your resultant velocity. Now the thing is, I don't have the exact diagram, but this is what you all have to do. You're going to have to figure out what the scale was on the diagram that they gave you, right? I'm not sure what the scale was. So you probably would have had to measure the length OA, right? In whatever cm it was, centimeters or whatever. So all they want us to do is to measure this, let's call it C. You just need to measure the length OC and that's it. That's all you all need to do. And I think the last part of the question, they wanted you to get what is the direction in degrees from the wind's velocity OB, right? So in that case, all we need to do there is to measure this angle. So you all would have had to use a protractor to measure that angle, right? Right, so I might be able to measure the angle with some degree of accuracy, but not so much in length. I don't know what length you all got. Let me see something. If I measure this here, what length am I getting? You see, this is not the actual size of the diagram, right? So my scale will be off, but the angle should be the same though. Let's see. How much you all got? About 10, 11, 12, maybe I get something like 13 degrees, right? But it depends on how you draw it. Right, so it's about 13 degrees. That's what I'm getting here. Right, so the length, it'll depend on your diagram. All right, so that is question 2. That's it. All right, so for this one here now, they give us a table. We have some thermometers, type of thermometer, use and range. Now, measures extremely high rapidly. You see this word rapidly changing temperatures? For any time you hear that, you should know that this is a thermocouple. Right, that's it. That's a thermocouple. As soon as you see that, that's what it is. The next one here now, we have about 34 to 43 degrees. So that's a limited range there. So that type of thermometer there has to be a clinical thermometer. Right, and use, right, to measure body temperature. Right, that's what you're going to put there. The next one mainly measures boiling point and freezing point and room temperature. So what we're talking about here is a laboratory thermometer. Right, and the range for this thermometer is minus 10 degrees C, right, to 110 degrees C. That's it. Right, so if you all didn't remember that, that's basically what it is, right? Oh, sorry. Yeah, my bad. All right, so yeah, so I didn't switch the screen, right? So here's what's happening here. So this is what the answer should have been. Once you see rapidly changing temperatures, we're talking about a thermocouple, right? The 34 to 43 degrees Celsius, that's this one here, right? This is a clinical thermometer we're talking about. And what do we use it for? We use it to measure body temperature. That's it, right? And the last one, they said this one here mainly measures boiling point, freezing point, and water. Right? So that's a laboratory thermometer we're talking about there. And the range for that is minus 10 to 110 degrees. Right? That's what we're looking for there. Right? All right, so that's part E. Let's move on. state the value of the ice point. So when you're talking about ice point, right, on the Celsius scale, that is simply 0 degrees Celsius, right? And then I noticed some people, they were wondering what is that temperature on the Kelvin scale, right? That temperature, all you need to do, if you know the degree Celsius, just add 273. So this here should have been just 273 Kelvin. So some people saying negative 273, right? It's 273. Right? So they're talking about the ice point here, right? That's the melting point of ice or the freezing point of ice. 1 mark for each of those things. The graph in figure 3 shows how the pressure varies with 1 over V and state the law. So you have to know your laws. So if P is inversely proportional to your volume, that is Boyle's law. So that's what I want here. Right? So 1 mark just for stating that. It is Boyle's law. I see some of you are saying negative 273. Right? The answer is 273, not negative 273. Right? Alright, so they have a graph here, right? They have a graph here. And what they want. Use a graph in figure 3 to determine the volume when the pressure is 250 kilopascal. So your pressure is equal to 250 kilopascal, right? And we want to know the volume. So where is 250? So we need, let me go back to the first question. I need to borrow a line here. I don't know if you're all seeing this, but I might have to make this a little thicker or darker or something. All right, so we're reading off at 250. So 250 is around here. So they're giving us easy graphs to read off, guys, right? Now your challenge now is to read the bottom piece. All right, I didn't copy this properly here. So let's see. All right, so that is, all right, so this is 0.015. So that 1 over V reading that I'm getting there is 0.018 cm to the minus 3, right? That's what I'm getting from this graph here. I think, yeah, that's what I'm getting. It look like that. Or is it 0.19? Hold on. I hardly see any graph here, right? So let's know. Actually looking closer to maybe 9 instead. Yeah, I feel it's closer to 9, right? So this is what I'm getting for my 1 over V. But the question says, calculate the volume, right? So P is 250 kilopascal, right? From the graph, 1 over V, I'm getting 0.019, and this is cm to the minus 3, right? But the question says, what's the volume? So you all have something to do here. So volume, right, is simply going to be 1 divided by 0.019. So that volume there is going to be around 52.6. Right, 52.6 cm cube. Yeah, but I seen you all saying you got 0.0019, but that's not the answer. You have to work out the volume, right? So you need to work out the volume. You have to find 1 over that. All right. So that's the answer there. Use your answer to C to calculate the new volume when the pressure is increased to 975. Now, this here we already established that it's Boyle's law. So therefore the formula that we're going to use is P1 V1 equal P2 V2, right? They said use your answer. So our initial pressure P1 is 250 kilopascal, right? Our initial volume is that volume that we just got there, which is 52.6. Right? And P2, they told us it's 975 kilopascal. And V2, we don't know. Right? That's what they want us to work out, calculate the new volume. So we start off with the formula P1 V1 equal P2 V2. So P1 is 250 multiplied by V1, which we just got as 52.6, is equal to P2, which is 975, multiplied by V2, which is what we don't know. So therefore, 975 V2 is equal to 250 multiplied by 52.6. So therefore, V2 is equal to 250 multiplied by 52.6. all over 975. So let's see, 250 multiplied by 52.6 divided by 975, and I'm getting my new volume as being 13.5 cm cube. Right, somebody's asking if you should convert to meter cube. You don't need to, right? Once you are consistent with your units, you can leave it in cm cube. There's no need to convert to meter cube. Don't worry, man. I'm sure you all still get marks in the rest of the paper, right? So that's my third question. Moving on, right? Define the term pressure. So pressure. So this is a question some people said they had trouble with. Pressure is the force acting normally per unit area. So that's your definition for pressure, right? The formula is given by F over A, right? And they want, what is the SI unit? So the SI unit, right, is going to be Newton per meter squared, or you could say Pascal as well, right? So that's the definition, and those are the units we can use. Yeah, you should get marks for the working, right? I mean, if you see, if you have the wrong value for the volume, you're still going to get marks, right? So don't worry. Right, somebody said the pressure is force per unit area. Yeah, that's fine. If you leave out the word normally, this normally means at right angles. Eh? This word here means at right angles, right? Let's see what else they ask here. Now, I haven't worked the papers yet. Eh? I am now working the paper. So if you all see me making any mistake, just let me know. Right, I have not worked the papers yet. I'm not working it, right? Calculate the liquid pressure, right? So this is similar to a question that I did, right? Basically, you have water. You have a diver that is under the water, right? And he's at a depth of 0.5 kilometers, right? And what else they told us here? All right, so they gave us the density of water, blah, 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 blah. And they want us to calculate the liquid pressure that a diver experiences at a depth. 1 second. They gave us, I'm just checking to see if they give us atmospheric pressure, right? Okay, so here's what we need to do, right? The pressure on the diver here, right? Oh, all they wanted is the liquid pressure, right? So all we need to do is to use rho GH, That's our formula here. The density for the water is 1025 multiplied by G, which is 10 multiplied by H. And now understand why they give them 4 marks for this. You see this kilometers here? When you're using the formula has to be in meters. So 0.5 kilometers is actually 500 meters. So this here is a little catch in the question, right? It should have been 500 meters. That's what you're using in the formula. Right? So all we need to do is multiply that, and that's it. That's the answer. Right? So I'm getting a really big number. So I'm going to put that in standard form. So 5125000 Pascal, right? And I'm going to write that as 5.125 by 10 to the power 1, 2, 3, 4, 5. Right? So you could either give your answer like this or in standard form, it doesn't matter. So you get an extra mark because you have to convert the kilometers into meters. That's where the extra mark came from. Right? So all they wanted was the liquid pressure, right? All right, so 4 marks for that. Next part. Well, lots of people probably forgot to study this or didn't study this at all, right? Archimedes Principle. Basically, a body wholly, H-O-L-L-Y, or partially immersed in a fluid experiences an upthrust right equal to the weight of the fluid displaced. Right? I'm sure lots of students did not look at that definition at all, right? So basically, with Archimedes Principle, if we have an object that is in water, right? The object is going to have a weight that is acting downwards, but at the same time, it's going to experience an upthrust. But the key thing with Archimedes Principle here is this. Even if you just had put upthrust is equal to the weight of fluid displaced, right? That's it. This is essentially what Archimedes Principle is, right? Now, if you put kilopascal for the previous answer, that's okay. You'll still get a mark. Don't worry. All right, so 3 marks for that. Now, this part now, some students didn't know how to do this either. So you have a boat, right? It has a weight. So the weight of the boat is equal to 83000 newtons. That's the weight of the boat. And it's floating on seawater. If the density of the water is 1025, calculate the volume of seawater displaced by the boat, right? Now, here's what they tell us here. The boat is floating, right? What that means is that, let's say this is a boat, right? So what's going to happen here is that that's your boat. Your weight is going to act downwards. So that's your weight acting downwards. And your upthrust is going to be here, right? The upthrust is acting upwards. Now, the question wants us to work out the volume of seawater that is produced. Now, if the boat is floating, right, and your weight is equal to your upthrust, then we definitely know what the upthrust is. So your upthrust has to be equal to that same 83,000 newtons, right? That's your upthrust, right? Now remember, upthrust is equal to the weight, in this case here is water, it's equal to the weight of the water displaced. Right? So that 83,000 is the weight of the water displaced, right? So therefore, to get the mass of the water displaced, all right, if you all remember, weight is m multiplied by g. So if you want to get the mass of the water displaced, you have to take your weight and divide by g, which is 10. So the mass of the water displaced is going to be 83000 divided by 10, and it's going to be 8300 kilograms, right? That's the mass of the water displaced. Now we're going to have to use our density formula, right? So density is equal to mass over volume. So therefore, if you want to get volume, okay, the question says volume of water. So I know lots of students would have gotten this question wrong for sure, right? The volume of water is equal to mass divided by your density. So you have to take the 8300 and divide it by your 1025, that's the density of water. And this is going to give me my volume. 8300 divided by 1025. And you're going to get about 8.10 meter cube. Right, so you get about 8.10, right? 8.10. Right, so that's question 4 for 15 marks, right? Next question, question 5. Define the term longitudinal wave. So we did this the night before. If you have a wave that is moving this way, right, and the particles in the wave, if they are oscillating like this, then that's a longitudinal wave, right? So all we need to say here, the particles oscillate in the same direction right? You could even use the word parallel. Direction of travel of the wave. Right? That's it. 2 marks just for stating what that is, right? All right, the next thing they want, oh wait, what happened here? One second, my file is giving some trouble. Okay, so part B now, in the question, they said a wave train on which the points K and S and A and D are shown, right? So they have some points here, and we're looking at displacement, right? And we have position along the wave train. So this is not time, eh? So the question says, write 2 letters whose distance between them on the wave represents amplitude. So if you want to get amplitude, all we need to say, we could say something like AL, that's 1, right? Or we can say something like BN, right? Or we have even more of them. We can say CP, right? All of those are amplitudes. And the next one, they want wavelength, right? So the wavelength could be KO, or you could tell them LP, right? So there are multiple answers here. You could even say NR, right? All of those represent the wavelength of a wave. All right, the next one, state 2 differences between light and sound waves, right? Easiest one, and I said it the night before. So light all right, is a transverse wave. Right, and sound is a longitudinal wave. Right, that's one difference here. The next difference is that light travels at, now you don't need to quote the exact figure, right? All you can say is light travels faster than the speed of sound, right? So light travels at that and sound travels. So if you don't remember the exact figures, that's okay. Sound travels at 330 meters per second, right? The next thing is, so our next thing is that light can travel through a vacuum. Right, whereas sound cannot. Right? Remember that sound requires a material medium, right, to travel. You can also say that light is an electromagnetic wave, sound is not, right? Any one of those things there. So there are multiple answers that you can accept here. I want you to see what you all have here. Yeah, so sound requires a material medium, right? Sound requires a material medium. It cannot travel through a vacuum, right? So a medium is required. Or you can't say light doesn't travel in a vacuum, a light does, right? Because light travels from the sun to the earth. That's a vacuum. All right, so that is part C. All right, so I did a question like this the night before as well. An object is placed 15 cm in front of a convergent lens. So therefore, this here is U, and the focal length is F, which is 10. Calculate V. So this is similar to what we did the night before. So the formula is 1 over F is 1 over U plus 1 over V. So 1 over 10 is equal to 1 over 15 plus 1 over V, right? So 1 over V is going to be equal to 1 over 10 minus 1 over 15. So therefore 1 over V is equal to, so calculator for this, 1 over 1 over 10 minus 1 over 15, and you're going to get 1 over 30. Right? So therefore V, that's what I want us to find, is going to be 30 cm. 4 marks, 4 easy marks if you know what you're doing. Right, so the answer is 30 cm, right? If you didn't get that, something is wrong, but it's 30 cm. And the next part, determining magnification. I did this the night before. Magnification is V over U. So that's going to be 30 cm divided by what we just got. Oh boy. $15, right? It's 15. 30 over 15, and you're going to get 2. Your magnification in this case here is 2. All right, what else they want now? State the nature and the position of the image formed. Now, we got V, right? We got V as being 30 cm, right? Now, in terms of a lens, so this is what's happening here. Your focal length was 10, right? Let's say it's 20, right? And the object was placed, what is that? 12 cm? I think it's 12 cm. All right, the object is placed 15 cm. Right, so the object is placed 15 cm, so the object is here, right? What that means is that that object, and we worked out the distance as being 30, right? So if this is 20 here, right, this thing here is being formed quite at 30. This is where you are getting your image being produced. So this is your object here, that's your image, right? They said state the nature and the position, right? So the image, let's start with the nature. So in this case here, when you place an object between your F and 2F, it's going to be a real image. So the nature, right, what they wanted here is a real image. It's not a virtual image, it's a real image. Right? And the position, right? So it's a real image, and we should also say that it's inverted. Right? And the position is going to be 30 cm on the opposite side of the lens. Right? That's it. That's all I need to say there. Right, I saw somebody say magnified. Yeah, you can put that if you want, right? Inverted, it's also magnified. Yeah, that's true. Because we got a magnification of 2, right? You see, what I'm looking at here is the amount of marks, right? So you probably need to put in a little more stuff inside it to get a mark. No, well, somebody's asking why the position can be inverted, right? When they ask you about the position here, they're talking about where is it located, right? And where is it located in reference to the object or in reference to the lens, right? Now, they're not going to ask you, they're not going to assign, right? They're not looking for these things here. What they're looking for you to say real, inverted, magnified, opposite. That's what they're looking for. You don't have to specify which one is which, right? You don't have to do that. All right, so that's it. That's question 5. Question 6 now. So some people got a little stressed with this one here. They couldn't remember certain things. They gave us some electrical components, and they want to know the symbol for a filament lamp, right? So this is what it is. That's it. That's a filament lamp. They want to know the name of the second thing here. That's a semiconductor diode. So semiconductor diode. A fuse, right? So basically we can use a fuse like this, right? I think there's a next one that looks something like this, where you have a box. This is another, any one of them could work for a fuse, right? The next one here, this is an AC supply, right? And they give you a space here for, I don't know why, right? And what they have here, they have cell. Oh, okay, so I see the problem. They made a mistake on their diagram. 1, 2, 3, 4. All right, so they might have to scrap this piece here because they made a mistake. I don't know if you all realize something here. This word here should have been cell, in which case, right, you're going to draw this for them. So they made a mistake in the table, right? There's a mistake in the table. And here, this should have been blank, right? And what this would have been here is a variable resistor. That's the word for this one here. Right? So they made a mistake in the diagram. I saw the space and I was wondering what happened there, right? So they're going to have to probably scrap 2 marks on this question though. No, that's not a rectifier. That's a semiconductor diode. We can use a diode to make a rectifier, yeah. But the The answer is semiconductor diode. Right? But if I'm not too sure if CXE told the examiners there was a problem, right? I don't know what they told you all in class when you went to write the exam. All right, so let's move on. A manufacturer of a popular cell phone has upgraded the battery. So I did a question like this with my class, right? Where I think we had upgraded the battery in some cell phone. So this is like a repeat question to tell you the truth. So the capacity, so that's charge here, that's Q. If the standard charger can deliver 0.8 amps, calculate the time taken to charge the battery. So formula, Q is equal to I multiplied by T. So therefore T is equal to Q over I. So your charge is 9600. And to tell you the truth, that number looks very familiar. I feel it's the same number. Divided by 0.8 amps. That's going to give me 9600 divided by 0.8. And yeah, this number looks very familiar to me. Right? So this is 1200 seconds. I show you the exact same numbers they use. Right, so 3 marks for that, right? Then what else they want here? Calculate the voltage given that the power supply of the cell phone is 4.4 watts, right? So they want us to get V. This here is P. So we need to find some formula. So what we could use here, we can use P is equal to IV. So V is equal to P over I. The power rating for this thing is 4.4. And the current, we just got, they told us the current previously was 0.8 amps. Right? It was 0.8 amps. So all we need to do is 4.4 divided by 0.8, and that's going to give me 5.5 volts. Right? I don't know if these numbers looking familiar to you all. Right? And the last part, determine the work done to fully charge the cell phone battery. So this one would have given some students some trouble, right? And this is a formula we don't see that often. So V is E over Q, or some of you all may have written it as V is equal to W over Q, because they want to know the work done, right? So let me use W instead actually. So actually this is a formula that defines voltage, right? So work done is equal to V multiplied by Q. So the voltage that we just got was 5.5 volts. Yeah, 5.5 volts. Multiplied by the charge. The charge was 9600. And that's it. 5.5 multiplied by 9600, and you're going to get 52,800. Joules, right? And that's it. This was a very easy paper, guys, right? This paper was easy. All right, so please hit like and subscribe, right? Even though some of you all may not have done so well, right? Please hit like and subscribe, please. Also, I do give online classes for maths, chemistry, physics, and art maths, right? So I can be WhatsApp at this number. My new cycle begins in August, right? All right, guys. So good night, everybody. right? These are the solutions for the physics paper for today, right? Take care, guys. That's it for me. I'm out. Later.